Okay, today we're talking about graphing. This is entry 4. Yeah, let's get started. Let's get it. So, presenting scientific data. A lot of times our data is best shown through graphical form, through a visual form. It's easy to see trends as opposed to a data table. So there's different types of graphs. Line graphs are one. They're best for continuous change. They're usually best with showing the x-axis is the independent variable, the one that we change, and the y-axis showing the dependent variable. So the dependent variable depends on what's happening. That's what we measure, and the independent variable are set, the values you choose beforehand. So let's look at a line graph. So here, time, they decided to measure time every 10 seconds. So the increments were set, and then they measured the change in volume as time went on. And then they just plotted those trends. So this is a line graph for continuous change. Notice the dots are connected. There are situations where we use a scatter plot, x and y, but we graph a line of best fit, and we'll get there later. So bar graphs compare items. Ooh, last thing I want to say about this is you want to notice trends. So you should be able to say as time goes on, the volume of the gas, specifically hydrogen, in milliliters increased until about what is this, 120 seconds, and then it leveled off. And we could look at the data table and say, actually at 140, it leveled off completely. So it's good to have both the data point in there. So bar graphs compare items. So, you can look at it different ways. These are melting temperatures. On this side, you have the different metals that we have here. It's useful for comparing similar data points for individual items or events. It can be clear how large or small the differences is. So you can be able to say very easily, iron is over double the melting point of lead, and so forth. Okay. What are the melting points over 1,000 degrees Kelvin or 1,000 Kelvin? It'd be gold, iron, and silver. And pie charts show parts of a whole. It's ideal for displaying parts data that is part of a whole. It's reflected as a percent, and notice that they're labeled and there's percentages in there. So every graph needs these things. Make sure you add this to your notes that you have a title. You have axes labels with units when applicable. So notice Kelvin's the units here. Here units aren't very applicable. There's a title though, so all those graphs have those things. There's a scale where you use 75% of the space. So let's go look at this one. So notice the graph doesn't go like up and then over and it takes up this much space when there's this much present on the graph. So you have to choose an appropriate scale, or in this case it's 10, 20, 30, 40. So it's a consistent scale up and down. A key when you have multiple data sets, all the ones that we looked at were labeled already. On a scatter plot, you have independent variable on the x and dependent on the y. This is the third time you've seen that, which hopefully is a sign that it is very important. Okay. So let's practice making some graphs. That's the most important thing here. So graph data from the table and the experiment below, and I just want to go through these together. So first thing, we have to decide which of these is my independent variable, my independent variable. Here is my independent variable here. Temp, I'm going to abbreviate just because I have to write it. And let's just assume it's degrees Celsius. Okay, it doesn't have one here. And then on this axis, my y-axis, I'm going to put sales, and this is in dollars. So notice this is kind of a bummer that side's so small. I apologize for that. You should have room on yours. And then for both of these, let's look at the numbers. They're always positive. So I can create a scatter plot here. So I got here. And then my title could be something like ice cream sales when weather's above 70 degrees, or whatever it might be. Ice cream sales versus temperature, something of that nature. So notice the highest temp is 91. Highest temp is 91. Highest sales is 230. So a nice way to do this is to count your number of squares, and yours might be a little bit different than mine. Mine's 1, 2, 3, 4, 5, 6, 7. $31 up. So I'm just making a note of that here. 31, and 6 across, and roughly 46 across. So temp is going over. So if I made all these into 2, you'd get, well, 92. Okay, so I could do that, but I'll probably do 5s instead. So it's 5, 10, 15, 20, and so forth. And I'm just going to pause here and write the scale in. So each one of these is going to be 5. That's a scale I decided. Scale I have here now, looking at it, I didn't know how wide your guys's were, so I didn't want to get too aggressive with it. But if I looked at this, I'd probably say I'd want to choose a slightly different scale because it is a little small. Okay, it's a little crunched. I'm not really using 3/4 of this. We're going to say it's fine for right now, but it is what it is. Okay, so here I got 30. If I do the same thing, each of these is 10, I'm going to get to 300. So let's do the same thing here. So this is 10, 20, counting all the way up. And I'll plot it out. I got 250. I'm just going to plot my data. I got 85 and 200. So here I go up to 85, go all the way up to 200, which is this line right here, and add a data point, and so forth for all of them. And once you take a minute to fill those in. Points now. Now your graph is going to look something like this. This cluster of data tells you that your scales are probably not very good. Okay, so that's where, going through this, it's fine for right now, but understand that if I see my data clustered like this, maybe I want to change my x-axis, my temp, so that it's more spread out here. So I have 1, 2, 3, 4, 5, 6, 7, 8 data points. 1, 2, 3, 4, 5, 6, 7, 8. And my goal now, I'm going to draw an align at best fit to get this trend. I should have about 4 above and 4 below my line when I draw it. And it should be a straight line, so it would look something like this. Okay, to draw my line at best fit. That's not that bad. Okay, and then this allows you to predict temperature and sales. So clearly, the warmer it is, the more sales you can predict to a certain point. The colder it is, the less sales you can predict. And again, with better scales, this graph would turn out a little bit. But align at best fit, again, it's half above, half below, and I'd probably add that into your notes here. Half above, half below. So now we got years of experience and salary. What I want you to do is make a decision in your mind. Which should go where? What am I measuring? What am I changing? About 40 marks that way and about 30 marks this way. So years of experience is what I'm changing. That should be on the x-axis, salary in thousands of dollars, which means this would be 15, that would be 28, and so forth, is right here. So years of experience, my maximum years of experience is 16, which means I could go 1, 2, 3, 4, 5, 6, 17, and 16 and get to like right here, right? So I'm going to skip 1 every time. So every 2 is going to be 1 year. So that'd be 2, 3, 4, 5. I just want to make, don't make the same mistake I made last time, which is making it too small. 6, 7, 8, 9, 10. And you should be filling this in as you go along. 12, 13, 14, and 15, and 16. And you could keep filling in until you got to 20, which would be 16. 15 is here, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so it should be about right there. Perfect. Now salary, I got to decide my scale. I have about 30. Salary goes up to 90 as my biggest. So that means 90, each one needs to be at a minimum of 3. I'm going to probably choose 10 just to make it, each one is 5 just to make it counting. So what I did there is I took my maximum 90 divided by my number of squares. 90 divided by 30 is 3, which means each square has to have a scale of 3 at a minimum. But I'm going to choose 5, so counting is a little bit easier. So fill that in by 5s on the y-axis. I counted instead of 5, 10, 15, I just counted by 10s here. Also make sure you put in your title up here. And make sure you did that on your last one as well. The title up here, okay, titles. And then lastly, you're going to put in your data points. and draw a line of best fit and make sure that that's done by your next one as well. By when you turn in your assignment, that's what I meant. Okay. And then we got one last graph here, or answer. Is there a trend present? If so, draw a line of best fit. So I want you to do that on your own. And then graphing data. Notice you have favorite vegetables, boys and girls, and you'd say number. So this one is going to be a bar graph, and since you have two different groups here, I'm going to need to add a key. I'm going to need to add a key. Okay. So you should have a key that has boys and girls, and they should each be marked with something different. So maybe boys is just a solid line, and girls is a semi-shaded line, and something like that by bars. So I'm going to do it this way. So you should have your different items down here. I'm going to have broccoli and carrots and so forth on that axis, and you're going to have your amount up this side. So amount of people, PPL, and then this is going to be the food or vegetable, veg. Okay, and then I should have graphs. So when I put broccoli here, let's say broccoli as an example. Oh, come on, it's not letting me type or draw. When I put broccoli here, okay, when I do broccoli, I'm going to do boys will be 2. Let's say each one of these was 1, 2 as such. Broccoli would go for the boys. This is very annoying. So I did 3 for the boys, and girls would be 5, which means I need to go up to 10. 2, 3, 4, 5. Draw it over, and then I'd have to shade it in. You're going to do something similar for all the vegetables. Boys and girls are right here. Okay. Last part you're going to do is you're going to go graph after you answer these questions. You're going to graph the Skittle. You fill in the data table here, and then you're going to fill it out however and graph it however you want. And then you're going to turn that in for your assignment. Make sure it's due by the next day.